Okay, so first of all, I want to take in exponential form. We have a base taken to an exponent is equal to some number. If you think of Ben, B-E-N, the base is the exponent and n is the answer that you get. When we write it in logarithmic form, we have the log, and log is an exponent. So we have log base, and that's a subscript, n equals e. So the log is the exponent. So it's taking the base b to the exponent e, getting n as the numerical answer. So if I had 2 to the 10th power is equal to 1,024, and I then wanted to write it in logarithmic form, I'd have log, the base is 2, the answer, when you raise 2 to the 10th power, is 1,024. So the exponent, or the log, is 10. This is 2 to the 10th power equals 1,024. If I have 9 as the base, to the negative 1/2 power, and we talked about this before, negative means you're going to take 9 and flip it over. 9 over 1, flip it over to 1/9. 1/2 is the square root. So when we take the square root of 1/9, we're getting 1/3. If I want to write this in logarithmic form, I have the log, the base is 9, the answer that you get is 1/3, and the power to which you're raising 9 to, or the log, is negative 1/2. We should also be able to take it in logarithmic form. The log base 2 of 64 is 6. That's in logarithmic form. To write it in exponential form, the base is 2, the exponent is 6, and the answer that you get is 64. So let me take and write them in exponential form. So the base is 5, raised to what power is equal to 125. Now what you can do is take 125 and break it down into 5 as the base. 5 to what power would give you 125? And 5 times 5 is 25, times 5 is 125. So the power to which you're raising 5 is 3. So 5 to the 3rd power is equal to 125. The next one, you notice there is no base there. And when there is no base there, it's the common logarithm. It means the base is 10. So we never write the base when it is 10. Otherwise, we do write the base. So this is 10 to what power is equal to 10,000. And that would be the 4th power. 10 to the 4th power is 10,000. 10 times 10 times 10 times 10. The next one is 2 to what power is equal to 1/8. Now if you think of 1/8, first of all, 8 as being 2 to the 3rd, and the fact that it is in the denominator means that it must be 2 to the negative 3 power. The negative means drop 2 to the denominator to the positive power. So that would be a negative 3 for the exponent. The next one is 3 to what power is equal to the square root of 27. So first, if you think of breaking 27 down into a base of 3, So 3 times 3 times 3 is 27. So we have 3 to the x power is equal to the square root of 3 to the third power. And then square root is 1/2 power. So x would be equal to 3/2. The power to which we're raising 3, and then the square root. So it's 3/2 power. So we have 16 raised to what power is equal to 2. So you think of 16 as 2 to the 4th power. But the fact that it's equal to 2, we have to have the 1/4 power. So it's saying, what is the 4th root of 16? What number times itself 4 times gives you 16 to get an answer of 2. The next one is 3 to what power is equal to 1? And that would be the 0 power, because 3 to the 0 power is equal to 1. The next one is 7 to what power is equal to 7? And that would be the 1st power. And the next one is 6 to what power equals 6 to the 7th? So therefore, it would just be 7. We already have the base. It's just saying x is equal to 7 then.